Good day, learners. We are doing video number 2 of momentum and impulses. That is the change in momentum. Then we said the momentum is the product of the mass of an object, the product of the mass and the velocity. And we said the momentum has the magnitude and the direction. It is a vector quantity, and the SI units for the momentum we said is kg meters per second, right? Don't forget to subscribe, to like the video, to share and comment. The change in momentum is represented by delta P. Delta means change in momentum is represented by delta P. That is the change in momentum. Okay, so what you need to know is that when there is a change in velocity, if the net force acts on an object, the object will change the velocity. The speed will increase or the speed will decrease. That is the change in what? In speed. So when the velocity or speed changes, which means the momentum changes also. It's either is increasing or decreasing, right? So the change in momentum is equal to the final momentum minus the initial momentum. That is the change in momentum. The change in momentum can also be equal to, remember that the momentum is mv. So this will be mvf minus mvi. That is the change in momentum. You can also take off the common factor, that is m, which is vf minus vi, right? And you must remember that the momentum is also a vector, which means we need to represent by using the vector diagram, right? So let's say we have the momentum initially, which is equal to 10 kg meters per second west, right? Then we have the final momentum. Let's say, for example, let's say it's 12 kg meters per second. Let's say west also. Then we need to calculate the change in momentum. Remember I said the change in momentum is equal to P final minus P initial. So it's P final minus P initial, right? Since we have west, so we need to choose the direction. Let's just say take east as positive. East is positive, meaning that west will be negative. Therefore, the initial momentum is negative, the final momentum is negative. Now, let's calculate the change in momentum. The change in momentum is final minus 12 minus the initial minus 10. Remember, we have this minus of the formula, then we have the minus here direction. So we have minus 12, negative times negative, that is positive 10, right? Okay, so minus 12 plus 10 is minus 2. It's minus 2 kg meters per second. Since it is negative, which means is directed to the west direction. So we have 2 kg meters per second west. So we have the initial momentum, we have the final momentum, we have the change in momentum. Change in momentum. Change in what? In momentum. Okay, so let's draw the vector diagram. Now, when we draw the vector diagram, what we do is to first draw the smallest one. That is the easiest way. This is the smallest one. Then this one is our number 2. Then the big one is number 3. Okay, so which means we are going to draw the change in momentum first. It's 2 kg west, 2 kg meters per second west. So this is the line directed west. This is our change in what? In momentum. Then we have number 2, that is the initial momentum, which is 10 kg meters west. So we have number 2, that is 10 kg west. This is our 10 kg west. That is the initial momentum, P initial. Then if you can look here, if we add 1 and 2, we get 3. That is number 3. Meaning that i-final momentum izodibanisa change in momentum and initial momentum, which means our line will be drawn from here to the last of the initial momentum. Then the direction is west also, so this is the direction. This is the final momentum. Then we are done with the vector diagram, which means we represented the vector diagram of the initial momentum, final momentum, and the change in momentum. Let's go to example 1. This is example number 1. Draw a vector diagram to show initial momentum, final momentum, and the change in momentum, which means we need to have the initial momentum, the final momentum, and the change in what? In momentum, in order to draw this vector diagram. A cricket ball, after being bowled, moves through air with momentum of 7. This is the initial momentum. Initial momentum is 7 kg meters per second. Then directed east. The batsman hits it in the opposite direction, so that the ball's momentum changes to change from 7 to what? To 10. This is the final momentum, 10 kg meters per second. The direction now is west, right? So we need the change in momentum. Remember we said change in momentum is momentum final, that is P final minus P initial. That is the change in momentum. Now we have to choose direction because the momentum is a vector. We said east must be positive. East is positive. East is positive. This one is positive. Initial momentum is positive. Final momentum is negative because it's directed to the west direction, right? So let's substitute. So the final momentum is minus 10. Minus 10. That is the final momentum. Changes to 10 kg meters per second west. The initial momentum is 7 minus 7. Then we get negative 17 kg meters per second. Since it is negative, change in momentum, since it is negative, so the answer is 17 kg meters per second negative west. So we have 17 kg meters per second west, right? So we have the initial momentum, we have the final momentum, we have the change in momentum. Now let's draw the vector diagram to show the initial, the final, and the change in momentum. Okay, remember we start with the smallest one. So we have 7, that is the first one, smallest one. Then 10, number 2, this one is 3. 1 plus 2 is equal to 3. 7 plus 10 is equal to 17. Okay, now let's draw the vector diagram. Let's start with number 1. Number 1 is 7 east. So we draw 7. So umgca wakho ke ngwabe mfutshane to represent 7. That is the initial momentum. Then we draw the final, which is 10 west. So 10 west. 10 is more than 7. That is the final momentum. Then the change is 1 plus 2, which is equal to 3. 10 plus 7 plus 10 is equal to 17. So the change in momentum will cover the 2, because when you add initial and final, you get the change. So when you combine the 2, you get the what? The change. So it will cover the 2. Then the direction is west also. So this is the change in momentum. This is the vector diagram. Let's go to example number 2. Example number 2. Draw a vector diagram to show initial momentum, final momentum, and the change in momentum. Remember, you need the initial momentum, you need the final momentum, then the what? The change in momentum. Then you draw the vector diagram. What do they say? A bullet is fired so that its initial momentum is 15 kg meters per second west. So we have the initial momentum, which is 15 kg meters per second west, right? It penetrates a cardboard wall and its momentum changes by, this is the change in momentum. Remember, in the first example, the question was saying changes to, so it's changing by 3 kg meters per second east, right? Then we need final momentum. So remember, the formula says change in momentum is equal to final momentum minus initial momentum. We start with final, then initial. Always final, initial, final, initial. Change in velocity is equal to v final minus v initial, right? So the change in momentum is 3, the initial momentum is 15, but we need to choose the direction. Remember, we said take east as positive. So this one will be negative, this one will be positive. Now let's calculate the change in the final momentum. The change in momentum is positive 3. The final momentum is what we are looking for, minus the initial momentum is negative 15. Then we open brackets, minus 15. Then 3 is equal to P final. Negative times negative is positive, positive 15. Then we transpose 15. We have 3 minus 15, which is equal to P final, right? P final. So 3 minus 15, P final is equal to minus 12 kg meters per second. Remember we said east is positive, which means this one is west. P final is 12 kg meters per second west. That is P final is 12 kg meters per second west. Right? Now, we need to draw the vector diagram. We do have the initial, we do have the final momentum, and the change in momentum. So we can draw the vector diagram to show initial, final, and the change in momentum, right? So what we do, we start with the smallest one. 3 is the first one, that is 1. Then this is number 2. Then this is number 3. When we add 1 plus 2, we get 3. 3 plus 12 is equal to 15. So let's start with number 1. So number 1 is 3 east. So I will draw a shorter vector diagram. That is our change in momentum. That is the first vector. Then the second one is final, that is 12. Then 12 is more than 3, far more than 3, right? This one is a final momentum. Okay, or the direction is east here, the direction is west here. So the arrow is supposed to be not in that side, west, final west. Then when you add a change in momentum and a final momentum, you get the initial momentum, meaning that when you combine the lines, you get the initial momentum, which means we are going to draw a line from here to here. Then the direction is west. This is a initial momentum. This is the vector diagram. Thank you very much. Don't forget to subscribe, like, and share. Thank you. Let's go to the next video, which is Newton's second law in terms of momentum.